All right, 5.4, we're still solving. All right, solving for log equations. A couple things we have to know. Again, we've been doing this the entire time. So we're still solving. You can still change certain things to exponential form, okay? So if there is one log, okay, put the equation into exponential form and solve. So exponential form means we're rearranging and we're solving for x. Now, keep in mind that's if there's one log, okay? If you have ln, we should know by now that ln is the same thing as log base e. So convert it to log base e, rearrange it to exponential, and then solve. Now, if there's one log on each side of the equal sign, okay, use the one-to-one property to solve, meaning cancel out what's the same and then just solve for x. Now, if there's multiple logs, condense it. Okay, we did expand and condense last time and use the one-to-one property and change to exponential form. So those are kind of the rules, whichever one you get. And again, we're going to see them in the examples. The most important thing here is log expressions are defined only for logs of positive real numbers. So what does that mean? If it honestly depends on what you get as an answer. If you get multiple answers, this kind of tells you the rule and what your answer is going to be. So inside of log, oh my gosh, what did I just write? It's inside of log, okay, and I'll show you that when we get there. Inside of log must be positive. So that means you cannot have, or your answer cannot be 0 or negative. Okay, and we'll see that, okay, in some of the examples at the end. So meaning if I get multiple answers, my answer cannot be 0 or negative. All right, looking at the first example, number 13. Oops. Okay, looking at the first example, number 13. I have ln of x equals 3. So in this one, I'm going to change that ln to log base e. So writing it, I have log base e of x equals 3. Now that I have log on one side, or I changed it already, I'm going to go ahead and put it in exponential. Don't forget what that means is you're going to switch them around. So I'm circling my base and switching the other two. I'm going to have e to the power of 3 equals x. Now, we should know how to solve this. Keep in mind I'm solving for x. I am going to get a number. We used this when we were solving for interest, when we were doing the compound money problems. So go ahead on your calculator, go ahead and push that e to the power of, and then plug in 3. So if we forgot, I'm going to go ahead and write it on here. In order for you to use that e, you're going to push second ln. ln. It says it on the board. It's e to the power of 3. So what it's going to look like on your calculator, it's going to look something like this. E with that little up arrow, open parentheses. Plug in that 3, and your answer for x, we're rounding to the thousandths place. It would be approximately, with the squiggly line, 20.086. If we forgot how to round, let me go over it really quick because you guys have to know how to round. So if you plug it in, you're going to get 20.0855. Thousandths is 3 digits. You're going to look at the one next to it. If it's 5 or more, you're going to round up. So in this case, your answer is going to be 20.086. All right, let's go ahead and look at number 14. Same thing. You guys can go ahead and try these ones. Same thing for this. So changing my ln to log base e of x equals 2. Okay, then because I have log base e, I'm trying to solve for x. I'm going to switch around. So I'm going to have e to the power of 2 equals x. Again, go ahead and plug into your calculator. All right, if you rounded correctly, x is going to be approximately 7.389 if you solved it and plugged it in correctly. All right, looking at number 15. Now for this one, do I have the one-to-one property? Yes. I have log base e on this side equals log base e on this side, canceling them out. And all I have to do is solve. Think of this as an algebra equation. I have 5x minus 1 equals x plus 7. We should all know how to solve this. I'm going to go ahead and subtract x to both sides of my equal sign. These x's are canceling out. I'm going to have 4 minus 1 equals 7. I'm going to add 1 to both sides of my equal sign. Oops, I forgot my x. And then I have 4x equals 8. And this one, you don't really need your calculator. All you're doing is dividing by 4 and x equals 2. Good. All right, looking at number 16, same thing. However, looking at this one, I have 2 log bases of 6 on one side of my equal sign. So in this case, keep in mind, this is where my equal sign is. In this case, I have to condense it. What did we learn last class? If I'm subtracting, what am I changing that to? Division. So I'm going to rewrite it. Okay, again, you have to condense it. So I'm going to have log base 6 with 3x plus 14 over 5. Keep in mind the first one is going to go and then on the top, okay, as your numerator, and then the second one is going to be your denominator. And I'm going to set it equal to log base 6 of 2x. Now looking at it, now I have my one-to-one property. Now I can go ahead and cancel out those log base 6's. And I have 3x plus 14 over 5 equals 2x. How do I solve for x? What do I do first? I'm going to go ahead and multiply by 5 on both sides. Okay, 5's are going to cancel out. I'm going to have 3x plus 14 equals 10x. Then subtract 3x from both sides. I'm going to end up with 14 equals 7x. And then this one's pretty easy. All you have to do is divide by 7. And if you divide by 7 correctly, your answer is going to be x equals 2. And you're done. So these questions are super easy. You just have to kind of rearrange things. And then all you're doing is solving like as if you're solving an algebra 1. Okay, orders of operations. All right, looking at number 17. Okay, so looking at 17, I do have one-to-one here. So I'm going to go ahead and cancel out those log base 2's. Cancel out my log base 2's. And then I'm going to have 2x minus 3 equals x plus 4. And then again, solving it algebraically, I'm just going to go ahead and put them both into 1. I'm subtracting x from both sides of my equal sign. And then I'm going to add 3 to both sides of my equal sign. Okay, if you solved correctly, you're going to end up with x equals 7. So that one should have been pretty easy. All right, looking at number 18. Okay, for this one, if you don't see a base, you're going to add base 10. Your 10 is your base if there is no base. Once you add the 10, you're gonna go ahead and condense these two. And what did we learn last class? When you're subtracting, you're gonna go ahead and divide. So now you're gonna have a log base 10 of 4x over 12 plus x equals log base 10. Let me change that. Of 2. I'm going to put these in parentheses so you don't get these two confused. This is my base. This is my fraction. The first one becomes your numerator. The second one becomes your denominator. Now you're going to go ahead and use that 1-to-1 property. Your log base 10s cancel out. And you're going to have 4x over 12 plus x equals 2. And then you're solving for x. So in that case, you're going to multiply by 12 plus x on both sides. Don't forget, you are distributing here. So looking at it, next step is going to go ahead and distribute. These are going to cancel out. You're going to have 4x equals 24 plus 2x. Next, you're going to go ahead and subtract 2x to both sides to get x by itself. You're going to get 2x equals 24. And then don't forget, last step is to divide by 2 on both sides of your equal sign. And x equals 12 as your answer. So all of this is just algebra 1 once you get to a certain point. And don't forget, you have to condense this if you're given 2 logs, following the rules that we learned last class. Now, looking at number 19, okay, for this question, we have to again try and get x by itself. First thing we're going to do for this is I'm going to subtract 5 to both sides of my equal sign. And subtracting 5, I'm going to end up with 2 times ln of x equals -1. To get rid of that 2, you have to divide by 2 on both sides. You're going to get ln of x equals -1/2. Okay, I'm going to go ahead and change that ln to log base e of x equals -1/2. And I'm going to go ahead and switch things around. Because I have log on one side, I'm changing it to exponential. E to the power of -1/2 equals x. Plug it into your calculator. Now, how do you plug this into your calculator? We use the e like we did with the money questions with compound last lesson, okay, last chapter, and we're still using that, the same thing for here. So on your calculator, you're going to press second ln. What's going to pop up is e to the power of, and then parentheses. Okay, you have to click the negative sign, not the subtraction sign. So the negative sign is next to the 0. If you click the subtraction sign, it's going to give you an error on your calculator. Then you're going to do 1 divided by 2. So it should look something like this. Go ahead and click enter. And it's going to give you a decimal. If you plugged it in correctly, your decimal is going to be x is approximately 0.607. What you had, keep in mind we are rounding to the nearest thousandths. And you're going to look at the number next to it. So that's how you're getting a 7. So please make sure you know how to enter it into the calculator. All right, looking at the next question, number 20, same thing, same process. I'm going to go ahead and subtract 7 to both sides of my equal sign. I'm going to end up with 3 elephant, or you know what? Let me do this part first. So if you want, you can go ahead and change your ln to log base e at the start. So we'll go ahead and do it this way. So I changed my ln to log base e, and I'm still doing the same process. Subtract 7 from both sides. You're going to end up with 3 log base e of x equals -2. And then you're going to go ahead and divide both sides by 3. So you're going to have log base e of x equals -2/3. And then same thing we did before, we're going to go ahead and write it in exponential. So circle my base, switch them around. I'm going to end up with e to the power of -2/3 equals x. And same thing we did before, you're gonna have to use that second button on your calculator to get E. And if you plugged it in correctly, X is approximately 0.513. And that should be your answer. So please make sure you check your work. All right, going to the next slide, let's go ahead and go to number 21. So looking at number 21, again, we're still trying to get X by itself. This is 2 times log base 3 of 3 times X. So getting rid of that 2, I have to divide both sides by 2. That gives me log base 5 of 3 of X equals 2. If you want to keep this in parentheses, you can. Now, because I have a log by itself, I'm going to go ahead and switch this to exponential. So I have 5 to the power of 2 equals 3x. 5 to the power of 2 gives me 25 equals 3x. And then dividing both sides by 3. Leave your answer like this. X equals 25 over 3. The only time you're changing it to a decimal or your decimal is when you have log, when you have ln, when you have e. But if you're just given a number, keep it that way. But if it's a fraction, it must be simplified. So please make sure your fractions are simplified. So looking at 22, same question. 3 times log base 4 of 6 times x. Divide both sides by 3. I'm going to end up with log base 4, make sure it's tiny, times 6 of x, or 6 times x, equals 3. Next, I'm going to go ahead and switch things around. Okay, now I have 4 to the power of 3 equals 6x. 4 to the power of 3 gives me 64 equals 6x. And divide by 6. Keep in mind, this can be simplified. X equals 64 over 6. But that can be simplified to 32 over 3. And that would be my answer. Again, if it's not simplified, it is not fully correct. You will receive points off. So please make sure you simplify your answers. All right, looking at the next one, let's go ahead and go over to 23. I have to go ahead and condense this. Okay, and looking at it, because I have addition, I'm going to be using multiplication, writing it condensed. Keep in mind there is no base here, so I have a base of 10. I'm just going to go ahead and write that base in. And now let me go ahead and change it. I'm going to have log base 10 of 5x times x minus 1 equals 2. I'm going to go ahead and distribute that 5x. Now I have log base 10 of 5x squared minus 5x equals 2. And because I have log by itself, I'm going to go ahead and switch some things around. Circle my base, switching the other 2. I'm going to have 10 to the power of 2 equals 5x squared minus 5x. 10 squared gives me 100. Okay, then looking at it, I can factor this. Okay, I'm going to subtract 100 to both sides of my equal sign. These are going to cancel out. I'm going to end up with 0 equals 5x squared minus 5x minus 100. Okay, I have a quadratic function. So a quadratic equation, I'm going to go ahead and factor. Before I factor, you can factor out a 5. So factoring out a 5 here, which gives me smaller numbers, I'm going to have 0 equals x squared minus x minus 20. So now it's easier for me to factor. So factoring out, what number multiplies to give me negative 20? And what number adds to give me negative 1? I'm going to have x minus 5, x plus 4, and solve for x. If you solve for x correctly, you should have had x equals positive 5, x equals negative 4. Going back to the first slide, we cannot have 0 or a negative number. So in this case, I cannot have -4. So my answer would be 5. Okay, so you have to remember that as well. Answer for this would just be 5. All right, and looking at 24, following the same steps, I'm going to go ahead and look at it. I don't have a base, so I'm going to go ahead and add that base of 10. And then I have to condense what I have. So condensing, I have a plus symbol. That means I'm multiplying. So now I'm going to have log base 10 of x times x minus 9 equals 1. Going ahead and distributing that x, I'm going to have log base 10 of x squared minus 9x equals 1. And then because I have log by itself, I'm going to go ahead and switch some things around. 10 to the power of 1 equals x squared minus 9x. Anything to the power of 1 is itself. And again, I have a quadratic equation once I subtract 10 to both sides. 0 equals x squared minus 9x minus 10. And this one I could just go ahead and factor. I have x minus 10, x plus 1, and same thing as before. Solving for x, x equals positive 10, and x equals -1. Again, I cannot have that negative. So I'm going to go ahead and cross that out. And my answer is 10. Okay, don't forget you cannot have 0 or a negative number.